Applications of trigonometry, solving right triangle problems. So, another way to give this title, all good, beautiful, thank you very much. Another title for this lesson would be word problems, which again, I think quadratics makes you, for the first time in your life, maybe scared of word problems. I don't think it's as bad here. I think you just have to read the description and come up with a picture. Okay? So we'll walk through a bunch of examples together. That's all. No new trig today. But if the trig isn't clear to you or you're not caught up on homework, well, then you get to re-see it here. Okay? So re-go over the trig, but in the process, we have to do the diagrams ourselves. That's all. That's the only difference here today, is that we'll have to build the diagrams ourselves. Here, let me get that for you, friend. Yes?
I'm trying to get on my note.
Say that one more time.
I'm just trying to get on my note. It's a bit
No, the other part.
Thank you, Mr. Todd.
You said you're the best.
Oh, you're the best, sir.
Yeah, thank you. I saw your hand up. I was trying to read your mind.
Oh, yeah.
That's what you need?
Yeah.
All right, here we go. Okay, to do this, I hope these are obvious statements when doing a word problem. You need to draw a diagram with side lengths and angles. I hope that's like, well, yeah, draw a diagram. Include a let statement for word problems. Show off all your work, including which trig ratio you're using, and write an answer statement. I hope the last one's like really obvious too, like, duh, I got to write an answer statement. Okay. Well, let's jump right in with what I think is the easiest of them and just go, let's just get warmed up on building the triangles ourselves. It says solve triangle ABC. I'm going to be looking for help in just a minute from somebody by what they mean by solve triangle ABC. That in a second. Where AC is 4, BC is 1.5, and B equals 90 degrees. I say read the whole question before you even start to try and do it. You know, just read the whole thing. I took one thing out of all that. Angle B is 90. Whew! That's relief for us. We need 90s. Are we always going to need 90s? No. Chapter not over. I'm going to deal with triangles that don't have 90. But this one has 90. And hopefully as that's happening, most of you are like, okay, well, if it's got a 90, I'm not too worried about this situation at all because I did my homework. I am great at right-angled trig, and this isn't going to be a problem. So let me label the edges here. Angle B is 90. Good, B is 90. And then there's ABC. Now, I can put the A on the top corner, I can put it down here. It doesn't really matter. Your picture might look different than other people's, but you get the same answers as them for the angles. So I'm going to put A up here, and I'm going to put C there. If you disagree with me, then everything that happens next, you might label it differently, but you'll get the same answers as me. And then it says, given AC is 4, we put that right on there. This is what the initial slide was saying. Draw the picture. Put the lengths all on there so you can see what the heck's going on. And BC is 1.5 centimeters. It didn't tell me what to find. There's no X on the diagram. There's no unknowns. What am I supposed to do? We're back to solve. What does solve mean? What's that? Okay, he's a step ahead of me in the sense that he's saying, okay, well, we can find AB. He knows he can find AB, all right? So if you don't know you can find AB, we'll talk about it in a second. But what does solve triangle ABC mean? What do I got to accomplish here? Everything. Find everything. So I've got to find the angles and I've got to find the sides. The good news is right angle triangles are very repetitive. There's not going to be a lot of thinking here. And I like Chris's plan. It's like, I can see what I need, what I can find here. I can find this. I'll label it X. Later on, we'll call that side C because it's across from the C. But you don't have to do that right now. We'll get a system going on how we label these. I'll just call it X for now. And what would I use, trig friends? I would definitely use math. No question about it. But this is just Pythagorean theorem. This is actually, you didn't need me for this. You came in and could do this. If you got two sides and you need to find a third, you're doing C squared equals A squared plus B squared. Now, I don't know how far along you are with the Pythagorean theorem. I'm far enough along that I go x squared equals 4 squared and 1.5 squared, and then I use my brain to decide if they should have add or subtract between them. Should it be subtract or add? Subtract. Okay, so if you're there, you're with me going, okay, I know the Pythagorean theorem was add, but if I'm finding something that's not the hypotenuse, I'm not using add, I'm going to use subtract, because that's the rearranging equation. If you're not there, if you're still writing down c squared equals a squared plus b squared, you're filling them all in and then rearranging. Hey, I love you. Wonderful. I love that move. But this is where it ends up one line later. So what I get is, well, you guys have wonderful calculators. So you will do 4 squared minus 1.5 squared. Will be 16 minus 2.25. Do you get 13.75? You will use your calculator, will you? Not too many people doing that in their head unless they've been here for 23 years. Just wandering through these. Wow, that's a weird triangle. It has sides 4, 1.5, and 13.75. I still have to square root that thing, yeah? So square root that 13.75. And I get x equals, oops, little oops there, 3.6, 3.7? 3.7. I can't do square roots in my head. Well, I can get them pretty close, but I can't actually I don't know how to actually get the square root in my head. I say, once you've done that, go right to your diagram and put it on there, just in case you need it for something else. Future science people, the original question had 1 decimal place, so your answer should have 1 decimal place. Lots of discussion of that in chemistry and biology and physics in grade 11 about how many decimal places make sense. Okay? All right, but this question says solve triangle ABC, so I got to find an angle. Which angle would you like to go after? And it doesn't matter what you choose. Which one? A? We're going after A, so circle it. Friends, circle it. I don't need to circle it. I know what I'm doing. Circle it. Circle it. Yes? Otherwise, you might get messed up. Because if I've circled that, what side is this? That's the hypotenuse. And what side was I given over here? Opposite. Now, here's just an advanced technique. You say, I've got adjacent as well. I know, but I calculated adjacent. I'll only use it if I have to. Because if I made a mistake there, I don't want that mistake to compound into other mistakes. So I'll go back and use the stuff that was given if I can. You can't always do that. But if it's possible to use what was given, that's a better choice. So you're not making a mistake here and using that mistake somewhere else. Yeah? What? So if I'm doing A and I have opposite and hypotenuse, sine, good. A lot of people now. It wasn't as many people yesterday. So hopefully you get to the point where it's like, even if it takes a second to go, so katoa, sine. So sine of A is opposite over hypotenuse. Sine of A is 1.5 over 4. Mr. Todd, my calculator doesn't have an A button. How do I do sine of A? Mike, you're not doing sine of A. Someone did sine of A and got 1.5 over 4. I've got to undo that. How do I undo it on your calculator? Sine inverse. It's called sine inverse even though it's got a sine -1. And you can totally be mystified and go, why would they use a -1 there? And I'm with you. It's not a great choice, yeah, for a symbol. Unfortunately, it is the symbol that you will see out there. So that means you hit second function sign. You got to hit the shift key on your calculator. Can you do it? Go shift sign, and then in the brackets 1.5 over 4. Who's got it? Let's see if we agree. He says 22 degrees. Anybody else? 22 degrees? Yeah. Let's just stop and savor that for a minute. 3 days ago, no, like by last Thursday, you would have thought that was impossible to get the angle from two sides like that. Now, it's actually pretty straightforward. Trig's pretty straightforward. In grade 10, get ready. Grade 11 gets it, because it's weird. At St. John's, if you say trig out loud, all the grade 10s go, I like trig. And all the grade 11s and 12s go, don't even say that word to me. Yeah? Because it gets things are going to get complicated. Anyways, we don't have to for now. Have I solved the triangle? Here, fill it in. 22 degrees. Nuh-uh. There's still one more to go. What's left? C. And you can do, to get C, you can go 180 minus 90 minus 22, but I just heard someone say something else. They're noticing that actually that's the same as just going 90 minus 22. In a right angle triangle, you can just go 90 minus the other angle. I don't really care which. I'm not trying to teach something bigger there. I just noticed that's true. And so I get C is 68 degrees. And I'm going to put that on my triangle as well. As the questions get tougher, you'll be happy when you fill them in on your triangle, just in case you need them. Do you have any questions about that? If you're caught up and you understood my lessons and done some homework, once I drew the picture, nothing new happened after that. That's true with all the word problems. Once we draw the picture, nothing new will happen in these, okay? But we get to review it, which is nice. It can be. Sometimes the picture is hard, and sometimes it's not. So we'll just have to, they're fairly repetitive in grade 10. That is, the examples I do today will look a lot like the examples you'll see all through the homework and tests and CCAs and stuff like that. Anyways, the distance between two floors in a new home is 2.5 meters. The horizontal length of the staircase is 2.8 meters. Determine the slope of the staircase. Well, I'm going to try and... You're like, not fair. It's not a slope chapter. Don't do slope. Yeah, we're doing slope. Here comes the picture. The distance between two floors in a new home is 2.5. Okay. The distance between the two floors was 2. There. 2.5 meters to get from floor 1 to floor 2. And it says the horizontal length of the staircase is 2.8. Horizontal is 2.8 meters. And I'm making it a triangle. I know they say it's a staircase, so if you're not feeling too good about my picture, like, where's the staircase? Here, you can put the stair. It's like, here's the staircase. Yeah? This is, you can draw better than me, but that's where the staircase is. If you really need to know, there's the staircase, okay? So then it says find the slope. Slope is easy and fun. Just remember, rise over run. It's right on the poster at the back of the class. Yes. Rise over run. 2.5 over 2.8. Now this is very confusing. It's like, you got decimals and a fraction. Please tell me that you shouldn't leave it as decimals and a fraction. Well, if you really want it as a decimal, that's okay. So what's 2.5 divided by 2.8? What do you get? .89. But if you just really want it as a fraction, you could do 25 over 28. That's pretty clever. I'm not really teaching that in this course. I'm making you aware that I could make it into a nice fraction if I wanted to. Yeah? Which part?
2 equal signs on one line.
Oh, yeah, he's so right. To go equals, equals like that, we don't like to do that at all. I hope you didn't do that in your note. I did it because just to fit it in there. Yes, okay. So I've never taken a mark off for that. I just mentioned it because it mostly doesn't matter until it does. There's a time in grade 12 where it's like if you go equals across the page, it might mess you up on what's going on, right? So, yeah. I teach math and do Rubik's Cubes. Does it seem like I made any effort to fit into society? No, zero effort to fit into society. Determine the angle of inclination of the staircase. I will call it A. I will circle it. Circle it. And if that's angle A, this is hypotenuse, which is fine. You can label it. If it helps you to label the other sides by putting hypotenuse on there, I like it. And then what's the 2.8 then? Adjacent. And 2.5 is opposite. So O and A, opposite and adjacent, 10. Tan of A is opposite over adjacent. Tan of A is 2.5 over 2.8. And it happens every year, friends. During the test, someone raised their hand and said, Mr. Todd, I can't find the A on my calculator. And I'm like, I know. Someone did tan of A, and they got this answer. And they're like, so what do I do? I'm like, well, you're going to have to undo tan. And they're like, how do I do that? And what would you say to them? How do you undo tan? Aloe, right, is the answer. No. And for the sake of the video, just in case you're watching this and you don't know how to do this in your calculator, let me get my calculator on the screen. And I'll do it, and then we'll compare answers, friends. In degree mode, tan inverse. Was it 2.5 over 2.8? Close the brackets to make it all look beautiful. Answer, do you get 41.7? 41.8. 41.8. I'll go to one decimal place. Therefore, the angle is 41.8 degrees. The angle of inclination. You can imagine these angles really matter. When you go to build staircases in houses, when you go to build ramps for wheelchairs and so on, it really matters what choices you make here as far as these angles are concerned. Yes. In fact, there's some rules about it. Yeah, so worry about that if you actually start building houses. Do you have questions?
Why would you have a 41-degree ramp?
Yeah, that would be a, yeah.
Even without a
I think it's 1 over 12. My brain somewhere along the way has read that it's 1 over 12. It goes 1 foot for every 12 foot over. I think that's right for wheelchair ramps. Yeah. Okay, this is the only part that might cause you some difficulty, I think. Angle of elevation, angle of depression. This picture is perfect. It's perfect to show you what angle of elevation, angle of depression is. This is how you would calculate the angles of view. If you were standing on a cliff looking up at an airplane, you'd calculate what the angle upwards would be. When you look straight out, you'd go, how far up is this thing? And if you were doing something that was below you, you'd do how far downwards from the horizontal. So it's always measured from the horizontal. So let's read this. If you're standing on a cliff beside a river and you look at a boat, the angle out that your line of sight makes with the horizontal, There's the important part. Horizontal, then up, or horizontal, then down, depending on whether you're doing angle of depression or angle of elevation. So that it says here, makes with the horizontal. Underline that. But look back at that picture. That picture really helps to understand what angle of elevation and angle of depression are all about. Yes?
There's 2 example forms.
Are they different examples? Okay, we'll fix them when we get there. Can you complain? Can you complain when we get here? Here's my question. What's the last one called? 5. So that's no good either. Yeah? All brand new. Actually, they're not brand new notes. They're retyped versions of old notes, but they are brand new. And so we're trying to fix the fonts and fix how they look and make new pictures. And so then there's mistakes in there. A search and rescue airplane is flying at an altitude of 1,200 meters towards a disabled ship. The pilot notes the angle of depression of the ship is 12 degrees. How much farther does the airplane have to fly to end up directly above the ship to make the save? Yes? This stuff really matters, actually. Yeah, you can imagine submarines and airplanes and everything flying around is really going to care about this. So, what do we got? A search and rescue airplane. Draw yourself a little airplane. I'm going to draw it up here. Let's see how good my airplane is. Mine looks more like a dolphin or a killer whale than an airplane. Hopefully you did better than me. It's terrible. And then there's a ship over here. I got big plans to be better with the ship. I'll draw the water. Why is he yelling at me? Draw the water. Okay. And then the ship will be green because it's covered in moss. Boat. Can you see the triangle? Like in your mind. I haven't drawn it yet, but you can see how trigonometry is going to help us here, because if I just draw a straight line down and then across here to the ship, I've got the right angle triangle I need to solve this problem. It's at that point, hopefully, that you're like, oh, this is going to be okay. Even that much of the picture, you go, okay, it's going to be okay. I got a right angle triangle. I'm good at right angle trig. I'm going to be able to handle this. Now I read the question again. I go, a search and rescue airplane is flying at an altitude of 1,200 meters. So the altitude here is 1,200 meters. Okay? Towards a disabled ship, the pilot notes that the angle of depression, that's with the horizontal. With the horizontal. So I say the horizontal, the easiest way to put horizontals on there is with just a dotted line. It's like, it's not an imaginary line, but it's like a line that I'm not really using in the question. There's the horizontal. So they measure this angle at 12 degrees, which is not in the triangle. Ah! But we can get now that we have that angle, we can get the angles in the triangle one of two ways. I know two ways. 90 minus 12. I could get this one over here. This one here is 90 minus 12. Equals 78 degrees. And then, you could do this question by getting the angle down there. There's two different ways to get that angle now. What two ways do you see to get this angle down here? You could do 180 minus 90 minus 78, and you'd get the 12 degrees again, which might be a hint that maybe I could have got the 12 directly by using the Z pattern. Yeah? So I don't know. You have to have all sorts of angle tricks available to handle that. Now what does the question ask? How much farther does the airplane have to fly to end up directly above the ship? So what I really want is this distance here. It's that moment you relax again. Your heart slows down. Happiness returns to the kingdom because you're like, I've got the label of the right angle triangle. Now I can do this. Which angle would you like to use? It doesn't matter which one you use. Really. It might change the algebra a little bit, but you'll still get the right answer. Which one would you like to use?
78.
I'm going to use the 12, and the only reason I'm doing that is because I'm trying to be a good teacher, and I'm going to walk us into trouble. Okay? There's going to be a little problem that comes up. And by little, I mean I hope it's truly little what happens here. So I'm going to circle 12, and that's the one I'm going to use because I can see what's about to happen. Because I've done 100 gabillion of them. Yes? But if it happens to you, I want you to be able to get out of trouble here. So I'm using that angle. What's the 1200? Yeah. It's the opposite. And what's the D? Adjacent. So this question involves opposite and adjacent. Opposite, adjacent, O and A. So, ka, to, a. Maybe you're going to write that in the top of your quiz. In the top, what quiz? On the test, you're going to write Sakatoa across the top to go there. Remember, sorry, so katoa. 10. So 10 of 12 equals opposite over adjacent. Let me fill that in, and then we'll have somebody be able to see what goes wrong that I saw coming only because I've done 100 gabillion zillion of them. What's the little wrinkle that's happened here? The tan 12 isn't a fraction. Oh, she's a step ahead of us. She knows what to do. But what wrinkle has happened that causes her to want to do that? Right, and where is the adjacent? And then the bottom. That's a little tiny wrinkle. And we'll challenge your algebra just a little bit. Because then you got to put tan 12 over 1, that's what Aubrey said. Cross multiply. But what happens is I get d tan 12. I don't get d equals. I get d times tan 12 equals. Is that no problem? I'm multiplying by tan 12. Divide by the tan 12. So that's a little wrinkle that can happen in these questions. So be careful with the cross multiply. Do not assume it's going to work out the way you want. If the unknown's in the denominator, there's going to be an extra step here. If you really knew what you were doing, you might have chose the 78 to avoid that problem. But maybe sometimes you won't know until it happens. So you want to be ready for it.
Why didn't we change the tan into a negative tan?
Because this time we had the angle. If you have the angle, you don't have to undo tan. We can do tan of angles. Yes?
Okay.
So then you type that in, 1200 over tan 12. $5,645.6 meters. Now hold on. Does that seem right? Maybe. 12 degrees is a really small number. This triangle I've drawn made 12 degrees look really big. 12 degrees should be like way off, to be 12 degrees, I'd have to be like way off the page here to actually get it to be 12 degrees. So when you draw these diagrams not to scale, don't be surprised if it doesn't look right. You got to think for a minute, and maybe in your brain you got to go over here and go, what's this triangle actually look like? If it's 12 degrees, it's more like that. So it does make sense. The math will get it right, maybe your diagram. It's just awfully tempting to build diagrams that are sort of close to being isosceles when this wasn't close to isosceles all the time. So maybe you learned a lesson. Maybe next time when you see an angle, you go, well, let me draw the picture. I don't have to get a protractor. Well, let me draw it close so I'm not surprised by the numbers that come up. Any questions about that one?
Why is the plane trying to figure out the distance unless it's trying to block the ship?
It's going to fly over here. It's going to drop a nice ladder down to help out the passengers. You're right, there are bombing applications here.
I think that's the only application.
No, you could go over there and drop this search and rescue. Yeah, we'd need a helicopter, wouldn't we? Yeah. You're going to drop emergency supplies on them. Captain America is going to jump out of the ship, out of the airplane, land on the ship, beat up all the kidnappers, and save everybody. It's in a movie. Yeah, Winter Soldier. So Captain America was up there doing trig on the back of his shield to get this worked out. A construction engineer determines that a straight road must rise vertically 45 meters over a 250-meter distance. These ones that give you a part of a diagram already are much easier, yes? Has to rise vertically 45 meters over a distance of 250 meters. Oh, measured along the surface of the road. Whoops. Yeah, over here, 250 on there. Along the surface of the road.
So that'd be the hypotenuse.
That's the hypotenuse, good. Calculate the angle of elevation. I want this angle in here, which I better change colors. That angle right there, which I'm going to circle. What are the two sides? This is hypotenuse. This is opposite, which we don't have. I've got opposite and hypotenuse. Sine. So sine of A equals opposite over hypotenuse. Sine of A is 45 over 250. Press sine and then your A button.
Do we need to do it in reverse?
Yes. What, you don't do sine of A. Someone did sine of A and got this answer. We need to undo that. And so to undo that to get the angle, we're doing sine inverse of 42 over 250. I get 10.4 degrees. Therefore, the angle of elevation is 10.4 degrees. Still pretty serious angle, actually. Even 10 degrees on the road is a pretty serious angle. Doesn't sound like much, but.
You know the hello sign I have? That's a right hand.
So that was example 4.
Walk up it.
For reals, was it?
At the hill.
That's actually example 4. The next one says 4 again. Do you need more time here? Next one says example 4 again. No, it's 5. If that kind of stuff bothers you. Jackie works for an oil company. She needs to drill a well to an oil deposit. The deposit's underneath the water. Yikes. So what she's going to do to drill the well is she's going to drill in at an angle there. So she doesn't have to go out in the middle of the pond and try and dig. Because we do this. There's oil rigs out in the ocean doing this. But it's fraught with peril. This is a very dangerous enterprise. If we can, we'll just go in at an angle. Yeah? So, the deposit lies 2,300 meters below the bottom of the lake. This distance is 2,300 meters. But the lake's 150 meters deep. The site is 1,000 meters from the point directly above the deposit. What color am I going to use here? Is blue going to show up? No. How about red? And this is 1,000 meters. This is 100. But no, how much is it? 1,000 meters. And if that mess, after drawing all that, messes you up, I'd be awfully tempted to go over there and go, okay, I got the gist of it. Here's my actual triangle here. There's 1,000 meters. I wrote 100 over here. And then what would this depth be 2450. And it says find this angle that she wants to drill at. Does it say that specifically? Jackie, where she needs to drill the deposit below the just from an angle from the side of the, oh yeah, it doesn't. Find the angle. I'll put that in the corrections. Find the angle. Oh, some people already zipping ahead of me. You hear the discussions going on now? As you practice more, it's like bang, bang. Yeah? The grade 11 physics people, they don't mess around with this very long. It's like, as soon as they're here, they're like, yep, that means that's opposite. That's adjacent. We're talking about tan. I'm not showing off. I'm not trying to rush you. I'm trying to show that once you practice this and get good at it, this should not take long. Tan of A is opposite over adjacent. And so A is the tan inverse of 2450 over 1,000. I get 67.8. Anyone else? 67.8? Yeah. Therefore, the angle of depression is 67 point. Angle of depression. I hate this stuff. I don't know why the English needs to use the same word for different stuff. It doesn't make any sense. There's lots of letters available. We can make new words. Yeah. There. What? Whoops. Two. And then there's tutu. Ballet dress. You're like, what are we doing? What are we doing? RR. Read, red. Never mind what they do with letters, right? Lamb. L-A-M-B. Lamba. Then there's lambda. Oh, that's a Greek letter. Lambda. Yeah. How many more of these I got to do? I'm losing it here. Last one? Oh, I got one more in me, but it's not example 5, is it? 6. The two triangle problem. Exclamation mark. Ooh. The two triangle problems are the ones that mess with students. Be careful here. Nadia, whose eyes are 1.65 meters off the ground, we're bringing that detail in. When you look downwards, you got to account for the fact that you have some height as well in all this. Anyways, Nadia, whose eyes are 1.65 meters off the ground, is standing on a cliff 130 meters above the water. Nadia looks down at an angle of 57 degrees from the horizontal to see Colton about to eat beaten by sharks. If you live in fear of sharks, I just want you to look up the comparison between how many people die from sharks and how many people die from cows tipping over. And I believe the ratio is about 10 to 1. You're 10 times more likely dying from a cow falling on you. It just doesn't happen that often. Sharks have a lot of good food in the ocean. They don't come looking for us very often. Anyway, shh. Nadia then looks up at an angle of 46 degrees to see Robert flying a rescue helicopter. Robert is directly above Colton, and due to weather conditions, he cannot lower the helicopter any further. Robert wants to save Colton by sending down the 220 meter longer rescue ladder. Will the ladder be enough? Draw a well-labeled diagram. I'm doing this on a separate page, but you've got enough room on your page, I think. Mine's sort of stretched, okay? Okay, here first. Cliff. Don't jump. Nadia. Usually on these diagrams, we make people a lot taller than they actually are so that we can label these things well. How high was the cliff? I already forget. Does anybody know? 130 meters. Nadia? 1.65 meters. Here's what I'm going to do. I'm going to overlay a green line on there. There's the actual triangle line there. How long is it, friends? 131.65 meters. A little bit different than the height of the cliff because Nadia's height is there. Could she lay on the ground and do this exact thing? Well, yeah, you could, but most times you don't do that. It's easier to get your rangefinder thing up at your eye level. Next. Colton in the water. Was it Colton that was in the water? Colton is very cold. He's been in the water for a while. And he's going under. It's almost over, folks. There's Colton. Sometimes one clever thing we do in math is we write letter C. If we have to label it C for Colton. Can you see the first triangle? Then, Robert. That's a really good. Are you talking about my helicopter? You must be making fun of me. It's not a right angle triangle. We can't do it. Don't give up. Here's what you really need on diagrams like this, is that horizontal line. Watch what happens. Now we got lots of right angle triangles. Can we do this problem later in the chapter without making right angle triangles? The answer is maybe. But it's easier as a right angle triangle question. We want this whole distance over here up to the top of the helicopter. We want to know what that is. So let's go back and see if we have any other measurements we can put on. 1.65, I used 130. Nadia looks down at Colton at an angle of 57. She doesn't look down on Colton. She's not judging him. From the horizontal down is 57. Good. Then she looks up at Robert. 46 degrees. See these little arcs I put on there to help you recognize how much we're talking about there. Just that much there. So, but do we have any other info? Well, we do. The ladder's 220 meters long. I can't use that yet. That's what I'm comparing to at the end. We hope. We hope Colton's going to make it. Yeah, I don't know. From helicopter to Robert. That's what we really want to find. I've already got part of it. I'm well on my way. Look at, see this distance? The cliff to Nadia is 131.65. I've already got that there. So let me just draw that on here. I've already got that distance there. I'm halfway there. Well, mathematically I'm halfway there. I'm not. Well, now we need someone who's right on the case to know what to do next. Because this is what I really want in here, right? I really want this distance here. But that triangle only has an angle. It doesn't have a side.
Well, yeah.
We could get angles.
We can go
I can get this angle, I can get that angle, and I still won't be able to do anything.
we can do 131 plus x for the top angle and use that as a side.
I actually think that might work. But it'll be more complicated than what we're doing. So we might have to wait a couple days to finish that strategy. I'm going to get out my highlighter. And I'm going to highlight something in red that's really important. My only really good teaching today, to be honest. So strap in, like pay attention. My little baseball team, I told them to actually hold their own hand so that they can pay attention because they're fiddlers, right? Pay attention here. In any double triangle problem, the side that is common to both triangles is really important. That's how we're going to get from one triangle to the other. If we're going to be able to use the information from the bottom triangle and get to the top triangle, that's the side we really want. You can dance around, you can do all sorts of stuff, but in the end, that's the side I want. If I get that, not only do I solve for that, I get new information for the new triangle. Let me say all that again. When you have two triangles, the side they have in common is vitally important. That's what you really should chase after. Don't try and get the question mark side yet. Go after this. And watch what happens when you get it. That I can do. We've been doing that all the way along. An angle and a side. So I'm going to use 57. They've given me opposite. I want adjacent. I'm running out of space here. I'm going to go back and forth. I hope that doesn't mess you up. I'm going to go back and do the calculation on the previous page. But for you, I think it's all on one page, so it should be okay. Tan 57. Oh, I'm doing B here now. Tan 57 equals opposite over adjacent. And in that bottom triangle, tan of 57, the opposite is 131.65. And the adjacent is x. Who's 2 steps ahead of us? What does this mean? What has happened here? Put it over 1. And when the x is in the denominator, you've got an extra step of algebra to do. It's not too bad. I get x tan 57 when I cross multiply. And are you okay if I just write 131.65? Because 1 times 131.65 is 131.65. Then I got to divide, right? Yes? Take the 131.65. And I get the answer for x. I'm very happy with what's just happened here. We had a lot of chatter and side jokes and all sorts of stuff we were doing there. And then the tough example came up, and it sort of went quiet as everybody went, wait a minute. Better start paying attention here and get locked in. 85.5 meters. Put that on. Remember I said put that on the picture? Every time you get something, put it on the picture. And I think someone say out loud, oh, I see what we're going to do here. Once I label that on there, do you see what has happened now? Now I'm into the second triangle. So don't get intimidated by dual triangle questions. Just look for that common side. Say, can I get the common side? If I get the common side, it's not a 2 triangle question. It's 2 1 triangle questions. Yes, if you know what you're doing. So now I go up to the top one and I go, okay, now I'm going to go after 46, which I'm going to circle a slightly different way, so I know what I'm doing here. And so I'm going after 46. It's opposite and adjacent again, though. And I'm going to call this H. Whatever letters you want, it doesn't matter, as long as you label them in the spot. So I'm doing now tan of 46 this time equals h over 85.5. Is this one going to have the extra step or no? No, because the unknown's in the numerator. That's a little tiny, like this much easier. Like it's like one step easier. Put that over 1, and when I cross multiply, I get h equals 85.5 tan 46. And we're moments away. Meanwhile, Colton's down there going, can you hurry up with the calculations? Really want to find out if I'm going to live through this or not. You're so right that in real world situations, you wouldn't be sitting here doing these calculations. But as you were flying in from port, you might be doing these calculations going, Captain, we're going to have to risk it. We're not going to make, the ladder's not going to make it by my calculations. You're going to have to go lower. And the captain goes, nope, I can't risk the helicopter. Colton's on his own. Or you go, nope, yep, we're going for it. We're going downwards. Times. Due to weather. It's windier down near the water. 88.5. Now, the big question. Is he going to make it? What did you do? How did you find out? What did you add? T for total. Total distance equals. Take the 131.65 and add the 88.5. Don't write it on one line because people will yell at me if I do that. And you get 220.65? 220.15? 222.15? No. 220.15. Ha! 15 centimeters. Are Colton's arms 15 centimeters long? Yeah, we should be okay. Now, and actually, we're really close to real. We're joking around, and I know it's Colton and silly sharks and stuff like that. But we're really close to real world problems where you have to go, yeah, I think that would make it, or no, I don't think it would make it. Technically, I guess it didn't make it. But me as a teacher, I'd just be looking for a therefore statement where you explain your answer. Therefore, I think Colton can reach it. It's 15 centimeters. Yes? Therefore, Colton should reach it. What actually happens in these situations? Usually a rescue person goes down the ladder because this person in the water is usually so tired they're not reaching up to hang onto a ladder. So they send someone down. They drop in the water. They hook them on. They stay in the water for a little while because they've got the hyper suit on, or they come down with a harpoon gun. Or yeah, obviously in real world this would be different. But do you have any questions about that?